Okay, so now let's go over some rules for the trigonometric functions. All right. So the first one is, what is the integral of sine of x with respect to x? Okay, now the rules for antiderivatives, they seem a little bit backwards from the normal rules for derivatives. So when we talk about the derivative sign is just cosine, and the derivative of cosine is negative sine. Now the rules are going to switch. So the integral of sine of x is negative cosine of x plus c. Now why would this one be negative? So think about this. Whenever you differentiate this side of the problem, you better get sine of x. And so when I take the derivative of cosine is negative sine. So I have this extra negative right here, so the negative and the negative, they cancel each other out, and you do get positive sine of x. All right? And so the integral of cosine of x with respect to x is just going to be sine of x plus c. And so if you think about this, well, what happens when you take the derivative of sine? You just get cosine. So that's why this one doesn't get an extra negative, is because if you differentiate, well, differentiating the c is just 0, but if you're differentiating this one right here, you're just getting cosine. So let's say, maybe I'll think the integral of secant squared of x with respect to x would be. Okay. So whenever you're thinking about this problem, what you really want to think about is, if I took a derivative of something, what could I take the derivative of that would give me secant squared? Well, the derivative of tangent is secant squared. So the integral of secant squared is tangent. All right, so let's talk about the integral. Let's say secant x, tangent x, with respect to x. So the question you have to ask yourself is, if I took a derivative of something, what would produce secant tangent? Okay? Well, the derivative of secant is secant tangent. So the antiderivative of secant tangent is secant. We can do these for cotangent and cosecant as well. So let's say the integral of cosecant squared of x with respect to x. Okay. And remember that the rules for cotangent and cosecant are the same rules for tangent and secant. Just whatever you do, there's always going to be an extra minus sign. Okay? So the derivative of cotangent is negative cosecant squared. Well, this thing's not negative. So the integral of cosecant squared of x is going to be negative cotangent of x plus c. Okay? And so if we did the integral of cosecant of x, cotangent of x with respect to x would be negative cosecant of x plus c. So just remember that if you remember the rules for tangent and secant, you know the rules for cotangent and cosecant, just they always get a minus sign. And this goes even further. Okay? So the integral of tangent of x is going to be the natural log of secant of x plus c with respect to x. Sorry. All right. So if we talk about the integral now of cotangent of x with respect to x, this is the negative natural log of cosecant of x plus c. Okay, so you always get that extra minus sign. And so the integral of secant of x equals the natural log of secant x plus tangent x plus c. And so the integral of cosecant of x would be the negative natural log of cosecant of x plus cotangent of x plus c. Okay, and I guess I can give a justification. Like, think about if we had the derivative with respect to x of the natural log of secant of x. This would be 1 divided by secant of x. Now the derivative of secant, which is secant of x, tangent of x. Okay, secant, they cancel each other out, and that just becomes tangent of x. And when we get to u substitution after this exam, we'll justify this even further by evaluating the integral using u substitution.